Okay. Hello, everybody. Welcome to the ngVLA Town Hall. So I am Alberto Volato. I'm one of the two co-chairs of the ngVLA Science Advisory Council. So the idea here is that before heading into the holiday season, which is going to look very different this year, we wanted you to have an update on the status of the project, especially in light of all the new situations that the pandemic has caused during these last several months. So the structure here of the town hall is going to be very simple. The first thing that will happen is that there will be a brief presentation on the project status that will be given by Eric Murphy, who is a project scientist. Normally, this would have been given by Mark McKinnon, who is the ngVLA project director, but unfortunately, he could not make it today. The next thing that will happen is Tony Beasley, the NRO director, will present a wider discussion of the general situation of the next generation VLA and the anticipated steps during the next several years and how we anticipate getting the next generation VLA into full science operations. And the last thing that will happen is there will be a question and answer session to the entire panel. You see there in the view graph the composition of the panel. So in addition to the people I have introduced before, we have Andrea Isela, the other co-chair of the Science Advisory Council. We have Rick Farnsworth, who is a project manager, and Rob Selina, who is a project engineer. So these people will be available to answer questions from you. And what we ask is that you ask your questions through the Q&A tool. You can do that during the presentations, and we will try to answer them live after the presentations end during the Q&A session. Okay, thank you very much.
Yes, Mark McKinnon, the project director, was slated to give this talk, which is basically a status report. You know, what we've been doing, so sort of the nuts and bolts of what we've been doing over the past year and what we're looking to do into FY21. So you know, since we haven't been able to really interact face-to-face over the past year, a lot of this information likely has been bottled up within the project. So this seemed like a very good way to disseminate it to the community. So just as a reminder, what is the next generation VLA? It is a brand new facility whose scientific frontier is aiming to study thermal imaging at milli-arc-second resolution. Sort of broad brush, the sensitivity and resolution goal of the facility is to achieve 10 times an order of magnitude better than what can be done with the existing very large array and ALMA. A frequency range that spans 1.2 to 116 gigahertz. So atomic hydrogen, the 21 centimeter spindle line at 1.4 gigahertz, all the way up to 116 gigahertz, which covers the CO, J equal fundamental transition of CO, J equals 1 to 0 line at 115 gigahertz, which of course traces the bulk of the molecular gas in galaxies. The overall facility is slated to be sited in the Southwest to leverage existing infrastructure at the VLA site, but spread out much further than the current footprint of the VLA throughout New Mexico into Texas, Arizona, and down into Mexico. All along, as we've been moving forward over the past, 4 or 5 years, we've been looking for a low technical risk facility, so we, not having to invent anything that doesn't exist yet to get this thing off the ground. So the baseline design right here, the reference design of the project is as follows. You can see up there on the top left that the array consists of a main array, which is 214 8-meter offset Gregorian antennas, which are those antennas that are sited in the US Southwest. There's a short baseline array of 19 6-meter offset Gregorian antennas to fill in the UV hole left by the main array, and then another 4 to 6 18-meter antennas that can be used in total Powerwall to fill in the UV hole left by the short baseline array. And then finally, a long baseline array, which it consists of 30 18-meter antennas located across the US. So existing VLBA sites, as well as some additional sites. So it's probably worth me pointing out now that, one of the sites that we added as part of the reference design was a antenna station in Arecibo. And this is for our phase calibration strategy to use with the VLBA station in St. Croix. So while it's very unfortunate as to what's happened in Arecibo, it's, the plan with the ngVLA has always been to bring, new capabilities to the island of Puerto Rico, and keep radio astronomy strong on the island there. So this design did not come out of thin air. It was completely formed out of these 5 key science goals that were defined through a community science use case capture process. So we opened up the floor to the community. Many of you for sure participated in this and took a bunch of science use cases, I think nearly 100. And then these were prioritized by our Science Advisory Council and distilled into these 5 key science goals, which I will read to emphasize a point. So unveiling the formation of solar system analogs on terrestrial scales, probing the initial conditions for planetary systems and life of astrochemistry, charting the assembly, structure, and evolution of galaxies over cosmic time, using pulsars in the galactic center as fundamental tests of gravity, and understanding the formation and evolution of stellar and supermassive black holes in the era of multi-messenger astronomy. So the takeaway is that these are very disparate science goals. They certainly cover many different facets of astrophysics. Thus, the design for the facility has always been to be as flexible as possible to accommodate these science goals. And I'm not going to go through them all, but I thought it's worth highlighting what really I think is the flagship science case for this facility, which is to build something with enough sensitivity, angular resolution, and frequency coverage to peer into the terrestrial planet-forming zone of newly formed solar systems and achieve AU scale resolution to make movies like these of planets forming. And I thought that this is actually something worth highlighting too. Some of you might be aware, we've run this ngVLA community studies program over the past few years, which has invited community members to be active participants in our design development activity, both on the technical front and the scientific front. This last year, we supported a study led by Kazu Akiyama and Lynn Matthews, which the aim of the project was actually to see how well SMILEY, the imaging algorithm, I think maximum entropy imaging algorithm used by the AHT, compared to CASA for some of these high resolution cases. And one of them right here is an AGB star that is pulsing. It has a 1.3 year pulse period. And this is an ngVLA simulation, observing it every 2 to 3 weeks, showing, this AGB star basically shedding its envelope in real time. So I thought this is actually pretty cool use case. Okay, now to more boring project stuff. So we have an org chart in key members of a project office. The leadership includes Mark McKinnon, Rick Farnsworth, myself, Rob Salina, and Alexia Nelwijk. We have 10 integrated project teams. Our project style definition follows the MREFC sort of guidelines. And we have very actively engaged science and technical advisory councils, and Alberto and Andrea are on here to sort of prove that point and keep us honest. We regularly meet the Science Advisory Council bi-weekly with the executive committee, have quarterly meetings with the entire group, and maybe not unfortunately not this year, but have annual face-to-face meetings as well. The overall project timeline. So we submitted the project materials to ASTRO 2020 late last year. We went through the whole request for informations and presentations. We're hoping for the recommendation from ASTRO 2020 to be published in spring of this year. That's the latest I've heard. It's unclear though if spring means March or June. After that, assuming a positive outcome, We are planning to submit a proposal to the NSF by the end of next year to enter MREFC candidacy. We are actively engaged in trying to get a prototype antenna, both built and delivered to the VLA site. And the hope was to get that there sort of 2024 timeframe and to 2023. I'll get into more details about that later because that has been a major activity over the past year. Then heading into 2025, complete the final design review for the MREFC design development activities and start construction in 2025 with early science operations sometime in 2028 when we have some sort of VLA-like capabilities available for the public or community to use, and then achieve full science operations early in the 2030s or mid-2030s, 2034, 35. So what have we been focusing on over the past year? So current goals has really been to be ready to react quickly to a positive Astro 2020 decadal survey outcome and advance the ngVLA conceptual design for MREFC candidacy at the end of next year. Current initiatives, we've continued to build and hone the ngVLA science case. This has been really driven by the community and coordinated by NRAO. We continue to update and incorporate additional science cases to the ngVLA science book and to our use case capture exercise. In fact, I actually just got another planet formation science use case about 2 weeks ago from a group in Mexico that we've now ingested into our formal document software. And then develop the ngVLA conceptual design, finalizing antenna design work and pursue a prototype, and work towards a finalist conceptual design to be externally reviewed in Q1 of next year, so the end of next calendar year. Status and performance, as you may or may not be aware, the ngVLA is now actually funded through its own cooperative support agreement with NSFs, which certainly demonstrates the fact that they are supporting us and consider us a real strong candidate for a next major facility. We have been continuing strong community engagement through participation through the SACs and other sponsored activities, and I'll get into some more details about that, of what we've done carried out over the past year, given the fact of the impacts of COVID. Updating our requirements and retiring risks through management and software engineering, as any good project should do, and continuing to identify and develop a broader impact and participation opportunities with each of our IPTs via a new strategic communication plan that's being developed by our broader impacts participation IPT. This is a slide that I've used a million times now, but we keep creating more and more participation on this thing. Either we have now many more industrial groups that have interacted with the project, and I'm sure I'm missing a lot here, but just to show that we really do have some strong community engagement via both international, industrial, and academic communities. So what have we done for community engagement over the past year? Well, the past 2 years, we've had science meetings, face-to-face science meetings, where I think we've done a very good job to gather early career astronomers. So, those are the conference pictures from the past couple of years, really showing, a lot of young and very happy folks who are excited to potentially use this new facility. Unfortunately, this year, which was slated to have our first actual topical meeting on multi-messenger astronomy, rather than sort of the broad ngVLA meetings we've been having, that got, sort of put to the side, and we're hoping to do something maybe next year. We'll see face-to-face. But what the LOC and SOC from that meeting decided to do was to host a short virtual meeting. So that was done over the course of 2 days, where each of the invited speakers just gave 15 minutes to talk. So 2 hours each day, less is more. And we, I think, had a very, very good showing. So for that meeting, over 850 individuals, predominantly graduate students and early career folks, registered. Over 650 individuals representing over 40 countries attended one or both days of that meeting, and the talks have been posted with nearly 300 views. And the other activity that was led by our Science Advisory Council, which I think was also extremely successful, was our short summer talk series. So, they worked hard to try to figure out a way to really keep folks engaged you know, with the exciting science that the ngVLA could do, and try to get, you know, world experts to talk about what they're interested in, and we would, you know, talk and see how it meshed with what ngVLA will be able to deliver. The goal of that series was really to have short talks, 20, 25 minutes, and be dominated by discussion. And that certainly happened. The talks ran for an hour. The talks were, or the whole event ran for an hour plus. But the talks were usually less than a half an hour, and we were really dominated by questions. So the short talk series, there were a total of nearly 800 individuals from 47 countries that attended one or more of the presentations. Average attendance was roughly 200, which is pretty much, I think, what we're getting here. And they range between 150, and we topped out at 380 for one of the talks. The participants came from well over 100 institutions, and the talks have been posted, and to date we have nearly or over 1,400 views for those talks. So I think we did a very good job over the past year of being agile and quick to change what we normally do to still keep people engaged. And this town hall is another example of this. Okay, and just to remind you, we have had and continue our international engagement. While last year we did have our first international science meeting, and we were supposed to be in Yokohama at the SPIE for a technical meeting that was canceled due to COVID. We still are working with our international partners or potential partners via meetings that is run by our technical advisory council led by Rob Salina, who is also on here, of course, our project engineer. So over the past year, what have we been doing from our homes and behind Zoom? Pre-COVID, we did, as I said, we responded and presented to ASTRO 2020, the program panels, and we had 2 rounds of RFIs and presented in person in February. So we've thrown that over the wall. We submitted an MSIP proposal for antenna detailed design and prototype. This is a proposal, while not accepted, is still in play, and the NSF is looking, I think, to hopefully find a way to help support this. We conducted a systems requirement external review over the past year. We're testing WVRs, water vapor radiometers, on the VLA antennas, as this is our preferred calibration strategy at the moment. We continue to develop our broader impact and participation plan, as I mentioned, ran the summer talk series, and have supported various science and technical meetings, albeit virtual. Another major activity over this past year, led by Joan Roble, was the construction of what we're calling the envelope observing program. So first, Joan put together the reference observing program, which was basically to show that each of the key science goals could be carried out with the ngVLA over some finite amount of time. So it wouldn't take 50 plus years to actually get them all done. We could get them done in a reasonable amount of time. And then this is now morphed into what a typical year would look like in terms of science programs on the ngVLA. And this exercise has been extremely important, as it is being used to inform the computing needs of the facility, as well as the operations concept. As you may or may not be aware, given the tiered array structure of the configuration, we're really anticipating using the ngVLA in a subarray sort of a request mode. So this is going to help inform that. And you can read this. This is a project document that has it's available online and is reviewed and approved. Other activities, we're working to update the configuration. So this is ongoing effort. We have the reference design configuration. And one thing that we've already done is changed one of the long baseline array sites. So we did have Westford, Massachusetts chosen, where Haystack is located. However, given both its proximity to Logan, I think it's 40 miles away, which results in a lot of RFI. And an analysis by Craig Walker, which finds it actually too close to Hancock, the existing VLBA site, to work for our paired calibration strategy. We've decided to move that now likely to Green Bank, which can actually now be used for paired and telebank calibration, both in Liberty in Iowa, as well as with Hancock. So we just find that to be a preferred site. And we're also looking for other ways to improve the snapshot coverage, both on the mid-base lines by extending things in the Southwest, as well as just with the antennas on the plane, maybe going from a 5-arm configuration to a 7-arm, thinning out the core. So this is all being actively looked at over this year, and we're hoping to get to a final or updated configuration ahead of the conceptual design review. Now, other major piece of activity has really been our antenna development. So there were 3 antenna cost of concept contracts awarded in FY20 to firms there, MTech, MTM, and Vertec, all German firms, basically trying to demonstrate that their antenna designs could fulfill our requirements. Then we had a second request for proposals that was actually due just last Monday, which included the costing information to see what a prototype might cost, as well as the getting through a final design review and a typical antenna unit per unit cost. So without getting into details of all that, I mean, I can happily say that what we did find from this effort over the past year is that both the antenna designs being looked at certainly can achieve or meet our requirements, and look to be able, and the costing estimates seem to be quite similar, if not better, than what we had conservatively assumed as part of our reference design that went to ASHRAE 2020. And here are 3 of these antenna concepts from those vendors. As you can tell, one looks much different than the other, a lot heavier than the other. But yeah, so this is some really nice work that has been done over the past year. So continuing on into next year. So what's our FY21 scope and plans? So we currently have 81 milestones slated for the ngVLA next year. This is a factor of almost 3 from last year. So we're really, it's full throttle ahead with the project. I've said this multiple times, but we're really pushing hard to advance the conceptual design to be consistent with the MRFC definition to really enter that MRFC candidacy. Select an 18-meter antenna design and further develop it towards a prototype. We're aggressively pursuing this prototype. Progress on towards the serial analog digital converters, the SADCs. So there's a lot of front-end work being done as well. Prototyping components for the correlator. Producing the updated configuration, as I already mentioned, for the CODR, development of advanced software and computing systems, and of course, continuing to engage and support the science community, work with all the IPTs to identify broader impact or opportunities for broader impact and participation through our design development efforts, and refine the project execution plan for MREFC candidacy. So issues and risks. Well, the first one that's really been hanging out over our heads has been the antenna cost from the preliminary design work, and whether or not the antennas for a given cost could achieve the goals. But we can, I think, confidently check that off as being met and move on to our other high priority or high risk items. Of course, there's always concern that cost estimates lead to capability to scopes, thereby inhibiting accomplishment of some of the key science goals. So working with the community, will always continue to refine and optimize the technical concept to make sure that any changes have to be made to the design, that we still are able to squeeze as much science of these key science goals out as possible. Of course, shortfall of funding for design development work post FY21 is an issue. So the project is, in our agile mode, always looking for other multiple sources of funding through other NSF programs. And of course, there's the concern that the project's fast pace may unconsciously overlook project stakeholders. And our mitigation for that is building this strategic communications plan. So we're actively always aware of our stakeholders through our design development activities. Quickly over the next 120 days, as we await the outcome of the ASHRAE 2020 final report, we're looking to award a contract for the antenna final design, continue the design development work, award our next round of ngVLA community studies. Those are actually, of course, due, I think, the mid-January. So, please, if you're interested, propose. We're hiring a new ngVLA research associate. The advert for that just closed yesterday. So we'll start looking at those applications. Continue to support ngVLA technical meetings as well as science meetings. A quick advert right here for our proposed IAU symposium for FY22 in Osaka, Japan on assembling planetary systems. As Andrea, who's online, is a SOC co-chair. So this is something we're trying to do to, again, improve our footprint internationally. So in summary, community engagement continues through science meetings, community studies, science and technical advisory councils. I think we've done a good job adapting to COVID, and I'm looking forward to when we go back the other way. Project management and systems engineering execution is ongoing. Working hard on the development of our conceptual design packet for MREFC candidacy. International industrial partnerships are ongoing, and we are aggressively pursuing the prototype antenna. And you know, with all this, really is possible only through the strong community support we're getting, as well as the support we've been getting through NSF. So I will end there, and happy to take questions after our next presentation by Tony.
Okay, good afternoon and good morning and whatever to everyone. It's my pleasure today to spend a little bit of time just talking about the overall development status of the project and kind of where we are in the decadal survey process. I noticed there are a couple of questions in there about things like decadal survey and Arecibo and so on, and hopefully through the course of this talk, I'll address some of those. Just as a little bit of a timeline here, I mean, I think many people on the Zoom meeting here realize that, you know, a telescope of this scale is a generational activity. If you look at something like ALMA or SKA or other big infrastructure projects, generally it's, you know, 10 to 25 years between the time the first ideas were thought about until the actual telescope might start construction. And that is also true for ngVLA. You know, some of the earliest ideas about ngVLA turned up in the 2000 era when the expanded very large array project was put together, EVLA phase 1 and phase 2. It had another name. It was called the A+ configuration at that point. Throughout the 2000s, a lot of the science that ngVLA is offering was discussed as part of the SKA High, which was thought to be a third piece of the SKA that would be deferred until the 2020s. So I guess we're doing that now. In the 2010 decadal survey, it was the North American array. And in 2013, we started to collect these ideas together and really think about how we wanted to move this project forward. So NRAO initiated the ngVLA project office. In 2015 through 17, we actually ran a set of community meetings where we looked at the future of radio astronomy in the US and really considered lots of different opportunities. And I'm very pleased that a lot of the themes that really bubbled up to the top of that Radio Futures series are things that we are seeing now in the decadal, have seen in the decadal survey, and really do point towards some of the exciting opportunities of this decade. After the Radio Futures series, we had a more focused set of meetings on ngVLA. Science program was developed in 2017. And over the last couple of years, there's been more than 24 major meetings and workshops and lots of different venues. Eric showed you a few of them, where we've brought the community together and brought the technical experts together to really think about what is possible. And that eventually resulted in a reference design. This reference design was first presented to the National Science Foundation in 2019, and then later to the decadal survey. And through the course of this year, we've been following up on that. As Eric mentioned, the design development activities are continuing, and we expect to be continuing a lot of that great work over a few years here, maybe 3 or 4 years, design development and risk reduction activities. In 2025 is what we're aiming at, to begin construction of ngVLA. And at that point, we'll also be thinking about how we transition from the current VLA, the JVLA, to ngVLA. And then in the longest term, 2034 on the schedule at the moment is the start of full science operations. So that's kind of the history of ngVLA, which goes back to the start of the millennia, really, and what we expect over the next 10 to 15 years in terms of bringing the project to life. Along the way, of course, you produce diagrams like this where you seek to understand what the telescope you're building and how it will sit inside, primarily here, the radio community, when you look at wavelength and frequency along the bottom and angular resolution on the side. And we also have the optical components up there. So, you know, we can do this in a technical sense where you sort of look at what the increase in resolution will be over what frequency range, and you can map out your phase space relative to other existing and planned telescopes. But then, of course, ultimately there's a science underpinning to this. And so in this case, for this diagram, you see there's the line where, you know, 1 AU at 140 parsecs. So this would be a terrestrial planet around, you know, TW higher or something like that. So, you know, by looking at diagrams like this, you can get some sense of how you sit relative to other instruments, but you can also understand, you know, compared to the absolute needs of science, what your new instrument will do. And it's quite obvious in this diagram, for example, that ngVLA, in particular with the LBA, is mapping out, you know, large new areas of potential science. The same is true for sensitivity. This is a diagram that shows ngVLA in a very good light and doesn't really do appropriate respect to SKA or ALMA, I would say. Off to the left of this diagram, SKA is an amazing instrument, and, you know, some orders of magnitude better than anything else that we have at the point. And that's also true off to the right of this diagram, where ALMA is absolutely amazing, above 100 gigahertz and up to a terahertz. And so, you know, in this particular regime between SKA and ALMA, that's really where we see, you know, ngVLA will be quite dominant and enable a lot of new science. And so again, by characterizing the project that you want to build and trying to understand how it fits into the, you know, the field of radio astronomy and astronomy writ large, that's how you move these projects forward. This is a science example of the same thing, and Eric showed this diagram earlier where we can look at the planet mass and the semi-major axis of planets that we're detecting with Kepler and other instruments. And we can see, you know, if the ELTs are built, that is the possibility in terms of exploring some of these objects, and then ALMA and upgraded ALMA, what it's capable of, and then you see what ngVLA is capable of. So both on the technical side and on the scientific side, you can very quickly develop some understanding of, you know, what step forward your instrument represents. And of course, that's how we then bring forward the project to the community and to, you know, Congress and the National Science Foundation and so on. That's how these projects come to life. Now, of course, particularly here in the US, we operate in an ecosystem. The way that ngVLA, you know, generates information and the type of science it does, yes, it can be somewhat standalone, you know, purely radio astronomy type topics, but more usually, I think, when we build instruments in the United States, you know, it's part of a multi-wavelength approach to a science problem. And so here you see on sort of similar timescales to the ngVLA instruments like SKA and LUVOIR and the US ELTs, TMT and GMT and so on. As these instruments come constructed and come online in the next decade, ngVLA will dovetail very nicely. And you can see kind of the list on the left-hand side there of what these other instruments, you know, are observing and the types of science they're doing and how ngVLA will contribute to that. And there's this sort of synergistic, you know, multi-wavelength science case that can be extracted. So really, ngVLA is very much part of this sort of arsenal of instrumentation that in the US and globally, we're bringing forward for the next decade or 2 decades to actually do, you know, very exciting science. Now, you know, NRAO's role in the community is really to support the, you know, the scientific ambitions of the community and to think about what instrumentation is required to get to the next level of science. And so in particular at centimeter and in the sub-millimeter, you know, the kind of the 2 ideas that we have locked onto over the course of interactions with the community over the past decade. One is thermal imaging on milli-arc-second scales. There's a lot of fantastic science that has been imagined there. And now ALMA has given us a hint of what is really possible with that. And then in general, just a, you know, a continuance of ALMA's general line of, say, millimeter and sub-millimeter, in particular spectral line work. There's, again, a lot of great science to be done there. So as we have thought about these problems and in discussions with the community, there are kind of 2 primary approaches here. So for thermal imaging on milli-arc-second scales, there's obviously an ngVLA approach here, where we are hoping to, you know, go through this design development phase, move into the ngVLA construction phase, and then ultimately into ngVLA operations. And along the way there's a transition between JVLA operations and ngVLA operations, which has to be talked about. And it's a complex issue. On the ALMA side, the timescales are a little different. At the moment, ALMA has been in full science operations for a handful of years, 5 years. And so there's still just a lot of amazing science falling out of ALMA, just with the, essentially the baseline instrument, the initial instrument. And so while we are doing upgrades, these mid-ALMA upgrades, as I've kind of indicated here, they tend to be sort of ×2 and ×4, and just in some sense improving, making the simple steps in terms of improving the instruments. But on longer timescales, there is an understanding that we will want to continue, the areas of research that ALMA is opening up. And so that's when you think about things like, having 10 times the spectral line sensitivity of ALMA. Well, for spectral line, a lot of that just kind of comes down to collecting area at this point. And so, when we think about the types of development projects and the types of construction project that would improve spectral line sensitivity, there's a period here where we, again, need to go through a design development focused on exactly these upgrades we want to make to ALMA. And then, sometime mid next decade, probably, we would align the partners and really think about sort of this larger ALMA upgrade. And this is something which is, an order of magnitude or more beyond kind of the development lines that we are currently undertaking with our European and Japanese partners on ALMA. And so that's a large project. Again, as I said, these are kind of generational things. And there are a lot of fantastic ideas floating around in the community about what ALMA 2030 should be. There's, ideas and proposals and so on. That's going to take some time to sort out here. And so, in the next few years, we need to sort of maybe make a gear change here and, continue to pursue the easy ALMA upgrades where we can, but really pivot and start to think about what a large upgrade of ALMA mid next decade would actually look like. So, these are very much the types of activities and the sorts of discussions that go on at NRAO. And to support all of that, you need technology. That there are aspects of what we need for ngVLA. We have examples of a lot of this technology, but we need better examples. We need antennas that don't need to be touched for 6 months. We need low power operations because, it's 10 times the number of antennas and so on. So there are technical developments for ngVLA which are required, sort of on the left-hand side there, and will flow into the construction of that instrument. Likewise for ALMA, you can see that if we decide that we want to increase the collecting area of ALMA by an order of magnitude up to 400 or 500 gigahertz, we need a development line there to look at the antennas that we might want to build in that line. Generally also on the ALMA side, we tend to think much more about much broader bandwidth receivers. Then you're throwing a lot of bits around the site, and so there's a digital engineering challenge. And then fundamentally with ALMA, there's also the field of view issue. We want to do larger areas on the sky, so you get into discussions of things like focal plane arrays or phased array feeds and so on. So, there are technical lines which need to be developed to enable some of those types of futures, if they are the ones that are selected, for, a 10 times ALMA upgrade in the 2030s. And all of this technology you see in the middle bar here, antenna designs, low power operations, digital engineering, LOIF distribution. We are working with university partners and our international partners in some cases to work on these technology lines. And this is absolutely an area where, as Eric has mentioned, we have funded, we have the ALMA development program, we have the ngVLA studies that we're supporting to help the community get engaged with us to develop these technologies to make these instruments a reality. Eric talked a little bit about the fact that, we continue to evolve the definition of ngVLA. I'm very pleased to say that actually over the course of the year here, with a lot of us continuously testing the design of the array, that really it hasn't changed very much. I mean, I think we've come quite quickly to a fairly converged design. There are still discussions of the details of antenna configuration. This is, this is a form of mental disease in the radio astronomy community. We always spend a lot of time on configuration studies, and we'll continue to do so. And occasionally, different opportunities turn up. As Eric mentioned, the opportunity for Green Bank there. In addition, in particular for the long baseline array, we have called out a design here which will enormously improve the high resolution performance of our observing capabilities here. And it depends on multiple sites for the longest baselines. As we know, some changes have happened. In Puerto Rico, there has been the incredibly sad demise of the 305 meter telescope. But we have strong plans for Arecibo. You know, we really want to get our ngVLA site in there, and that long baseline site's incredibly important to the design of the long baseline array portion of ngVLA. And so, you know, that's absolutely our interest. We've already had some discussion with our colleagues at the University of Central Florida. And we certainly have taken to the decadal survey a plan for, you know, a part of the future of the Arecibo Observatory. Obviously, Hawaii is a complex situation. You know, we do have an antenna on Mauna Kea. Exactly, you know, what will happen with that situation remains to be seen. But certainly, we plan to grow on the Big Island in Hawaii. And so that's not going to happen on Mauna Kea in any scenario that we can easily imagine here. So in that case, that's an example where we do want to think about relocating the site and thinking about, you know, more opportunity. Each of the ngVLA antennas is about as sensitive as a VLBA antenna was or is. And so, you know, replacing them one for one is not a bad match. But you can see on the left hand here, we're actually talking about creating long baseline stations, which are a factor of 3 more sensitive per antenna. So that kind of growth is important. And we see that, you know, we really want to pursue those opportunities in Arecibo and somewhere on the Big Island and build this long baseline array. Okay, just talking a little bit more about funding environment. These are the sorts of diagrams that traditionally the NSF has shown in terms of, you know, how their budget runs out. I can't say I've seen one of these for a couple of years, 18 months or so. But, you know, you see that the different instruments, NRAO and ALMA, NOAO and DKIST and LSST ramping up and so on. And, you know, a big problem in our community for several years has been the fact that the proliferation and the costs of the facilities tends to eat the entire AST budget here. And so you can see that the purple part, which is where a lot of the science and the grant support for people in the community comes from, whereas in 2010, say, or even 2000 and 2005, typically the facilities were about 50% of the NSF budget. In recent years, because of flattening and kind of the way the economy rolled out through the decade, there was some compression, and we got to very difficult times in terms of the number of grants that were possible out there. And this is actually a recent diagram. There were several years in the middle of the decade, middle of last decade, where you know, the AST budget was pronounced flat for several years in a row, in which case this compression of the grants at the top here, this purple piece, was very significant. Now, more recently, I think the situation has been better. Actually, truth be known, you know, over the course of the last 4 or 5 years, the funding environment has been okay. NSF has seen some modest growth, and AST has shared in aspects of that. And so you have diagrams like this now, where instead of producing the AST equals 0 growth and all of the issues that arise with that, we see AST is sharing in some of the overall growth of the NSF, and that's obviously a much more positive situation. It doesn't, you know, if you look at the 2020 point there, there's still, you know, a very difficult situation in terms of the compression of the grants program, but certainly driving along AST equals 0 is a huge problem in that arena. Well, you know, I think the NSF has also, as the decade has changed, started to think more ambitiously about the future of facilities and, you know, what the next big things in astronomy and other areas of science are. And so the MREFC account, Major Research Equipment and Facilities account, that the NSF uses to build facilities, this is a diagram where people talk about, you know, what are the opportunities, you know, what's the type of growth that might be required in the next decade to you know, really stay on the leading edge of science and continue US leadership in a lot of these key areas. And so you see here this kind of olive MREFC bar, where there's a sense that over the course of the second half of the decade here, the MREFC account, which typically, as you can see on the left-hand side here, bubbles along at about 200, sometimes bigger, sometimes a little smaller, about 200 million a year. Well, by the end of the decade, the plan is to have that up by a factor of 3. And that's fantastic. You know, this is really the NSF understanding that the future of some of these facility-driven science fields needs the investment in infrastructure. And so, you know, it's an excellent sign that, you know, perhaps we are all talking about the same thing, and there's a question of timing to be considered. So if we think in our community, you know, we are not, astronomy is not the only science that goes fishing in the MREFC account. You can see on the left-hand side here, well, there's LSST and DKIST, so there's 2 there. But there are other projects here, the modernization of the Antarctic Station, the instruments for the Large Hadron Collider and so on. But you can notice on the left-hand side of this diagram that those are sort of rolling out and ending in the course of the next few years. And so this is sort of the opportunity in some sense that is presented now, is that really bringing forward these large projects and being ambitious about the science we want to do, that is what the NSF wants to see, and that is what the community requires if we're going to be successful. So, you know, just in terms of the, you know, 2 largest things that we're sort of aware of floating around in the decadal survey. Well, there's obviously a lot of interest in this country for a US ELT, for US access to, you know, a large optical telescope. And so, you know, on some time scale here to be determined, this was information I received, you know, a couple of months ago now, I guess. There would be a sense that US ELT would start construction and try and get done by the end of the decade. As you know, is visible in Eric's diagram, although it went past quickly, you know, this is kind of what we're talking about for ngVLA, where we want to start construction and sort of ramp up and hit that pretty hard for a couple of years. So what you can see already is that even the notional increase of ambitious future for the MREFC account that the NSF itself is talking about is probably not going to cut it. That actually, if we want to build any of these projects, we probably need to be more ambitious, and the MREFC account really needs to get up to that triple level pretty fast. And so if that actually happens and things are timed appropriately, there's also some headroom for other projects, other astronomy projects and other projects in other sciences to get through. So very much in a sort of advocacy sense, this is the, you know, the message that I think the science community is trying to transmit to Congress and the National Science Foundation, is that there are remarkable science opportunities here, but we're going to have to hit it harder. We're going to have to, you know, revise the way that we kind of fund this situation to get to these, you know, important next science goals. One of them is this MREFC issue that we've talked about, but the other is that just in general, the NSF budget has to increase. So very much the mantra that is floating around now, and not just in the astronomy community, writ broadly, I think through the science community, is that we really want to push now for a doubling of the NSF budget and a tripling of the MREFC. In that kind of funding environment, all of our astronomy desires and some of the desires of, you know, the facility desires of some of these other sciences all become possible. So if you're sitting next to someone in a suit or, you know, dressed very well on a plane, actually, I guess this is a stupid analogy now, you know, and you're just talking to them about science in this country and so on, this is kind of the message, that really we want the NSF budget to increase here. We want to increase, in particular, the amount that's going into the MREFC to enable some of these futures. This is another notional diagram from the NSF of the R&RA account. This is the grants account. And this is really where you want to see this, you know, this is where the doubling of the NSF budget comes into play, because the MREFC from the previous chart is this little green wedge down the bottom. You see that a lot of money in the NSF does go out into the grants program, but it is, you know, currently insufficient to really fund the operations of these facilities we want to build and to continue to support the science and the grants programs and so on. So, you know, there's actually a, you know, a slightly modified version of the mantra that you want to say. So we do want to double the NSF budget. We do want to triple the MREFC. I think the other thing we need to do is establish kind of an agreed ratio of the grants to facilities in the NSF. I showed you on that previous diagram that historically, and it was actually true over long periods, that there was maybe a number like 50% or something or other. And in other fields and for other agencies like the Department of Energy and so on, Adam Cohen has pointed out to me, there is sort of an understanding. You know, the DOE runs labs and they also fund science. You know, there is some understanding of what those ratios should typically be. So as we move forward here, this is obviously a big goal, double the NSF budget, triple the MREFC, and try and put some notion of what the, you know, the standard ratio to grants and facilities would be. This will grow and stabilize our community and give us the headroom and what we need to actually move forward with these next generation of facilities. In terms of specific ngVLA support, we initiated the ngVLA project office with some money that I dragged together in 2013 and 14. NSF has supported us quite well over the last couple of years in terms of design development funding. We have a proposal under review looking at an antenna prototype. We've also had some great interest and support from our international partners. There's been in-kind contributions that would probably total a few $1 million from some of our international partners. So if you add all of that up, you're coming up to a number which is like 40 or 50 million dollars. And this is roughly 30 or 40% of the design development for ngVLA that will be ultimately required. So, it's just interesting. Sometimes I get this impression from people in the community that, has ngVLA really started? We're actually 30 or 40% into our design development here. And we're making the moves that are required to enable the construction funding to start within 4 or 5 years. So we're actually well down the path here. And a lot of that has been the fantastic support from the National Science Foundation and the community, but also, some of this great interest and investment by our international partners potentially in the instrument. So as we've progressed through the year here, Eric mentioned, we've had some COVID impacts, but generally we're making fantastic progress. We tend to be funding and staff limited. We can't launch all of the initiatives we want to in terms of the design development activity. And very much we struggle to, hire the people that will come in and do some of this work. And so this is where we need to work more closely with the community and think about what the opportunities are. Once we get past the decadal survey, and someone asked in the question, said, what's a good outcome in the survey? Well, a good outcome in the survey, I think, is being one of the highest ranked projects for the decade to come. Do you have to be number 1 or number 2 or number 3? I don't know the answer to that. We're anticipating being in that kind of area, one of those sort of numbers. So I think that's more than enough for us to move forward into construction here. Once we get past the decadal survey, we will need to see this remaining sort of 60 to 70% of design development funding over the course of 4 or 5 years to really get this thing into MREFC standing and get construction approved. So just in summary, in terms of the overall project, the design development processes are mature. We're benefiting a lot from everything that NREO and a lot of people in the community have learned from ALMA in the preceding decade. The instrument concept is quite converged at this point. What we're seeing is that our estimates are reasonable. Eric mentioned that we've reduced one source of risk in the sense that we have been out for an antenna evaluation and a prototype antenna contract. So we are currently evaluating a set of bids, and what we're seeing in those bids is that meeting our specifications is possible, and the types of numbers that are produced for those bids are within the cloud that we had expected at some level. So I think that's one area where we've beaten down risk. In lots of other places in the project, we also need to work on that. For the next 6 months, we'll see the decadal survey report. Hopefully we'll get this prototype antenna going, and we have lots of technical developments underway, etc. Our international and domestic partnerships continue to grow. We're continuing to talk to potentially new users and new interests for ngVLA. We actually just recently, the Canadian decadal survey was published, and there was a strong support as a potential Canadian interest for the coming decades. And just in general, we understand we're in a kind of complex global and domestic environment. There's a change of administration about to happen, and we have a pandemic, and we're kind of going through an economic crisis. These things come and go on timescales of a few years, and there'll be more in the future in general. But as we move forward here, the growth that's needed in the NSF is well within our capability. This is possible, and ngVLA represents a fantastic piece of new science, and we're going to continue to expand and think about US leadership in radio astronomy with it, and that's where the project is and how we're moving forward. So thank you.
So question number 1, I think is addressed to you, Tony. You're the best person to answer it. What constitutes a positive outcome from the decadal review, and what next if the outcome is not positive? So you partially answered this already. But...
Sure. So a positive outcome is appreciation and by the science community that the ngVLA is a high priority science target to be built in the next decade. So I don't know that necessarily corresponds to some number in the decadal survey, But, you know, I think that a high ranking is obviously important. What next if the outcome is not positive? Well, I guess we'd have to see why. You know, we'd have to understand exactly why the outcome was not positive before I could answer that. In general, I'm not expecting that. I think that we've done a lot of outreach with the community to talk about, you know, the properties of ngVLA, and I'm pretty confident that we'll be fine in the survey.
Okay, thank you. So next, I have a question about the plan for the old VLA dishes. So is there a plan for them, or can one think about a combination technique for niche projects? So what is happening to the old VLA dishes? And I think you can answer it, but Eric,
maybe I'll answer it. Yeah, so one thing we've talked about with our users committee and a couple of other different committees is that we have some ideas on how to generate a transition plan between the JVLA and ngVLA. There are some great questions, you know, at what point do you continue to observe and how many antennas and all that. The strict answer to Peter's question here is that there isn't really a particular plan for the old VLA dishes. Those dishes are 40 years old and they're still doing fine, but next year they'll be 41 years old. And so, you know, we don't tend to think about merging them into the ngVLA or anything like that. We have had proposals. There's been some commercial interest about taking them over and looking at things like satellite downlink from you know, lunar initiatives that might be going on. So that will be part of the story. We'll have to come up with some proposal for that. It has also been, it's also been discussed that there are perhaps particular observing opportunities that might be accomplished with the VLA antennas that might be considered in the future.
Okay, great, thank you, Tony. So the questions keep rearranging themselves since people vote for them. Okay, so next question at the top here. By locating ngVLA antennas farther from the VLA site, will these antennas have worse atmospheric conditions than the current VLA? Is there an estimate on the fraction of observing time that will be available for high frequency observations, 30 to 40 gigahertz? So I think, Rob, you are the best person to answer this, possibly.
Yeah, this has been an area of active study. We've got ngVLA Memo 73, I believe, which looks at the atmospheric phase interferometer at the VLA site and estimates availability by band based on 10 years worth of data for the main array. In terms of extending that analysis beyond the VLA site into the southwest and the LBA sites, that's still an active piece of work. So we don't have a good estimate yet by band for the full extent of the array. But it is worth noting that the initial results from that study, which we think will conclude in next year, so we should have something definitive next year, but it suggests actually pretty strong relationship for weather patterns across the Southwest. So VLA sites should be quite representative for Arizona, the rest of New Mexico, and West Texas.
Okay, thank you. So the next question at the top here. The ngVLA will offer open time. Is it expected that the ngVLA will then be able to operate in coordination with other VLBI facilities, like the VLBA does today, or will it be mostly a standalone facility? Are experts of these facilities participating in the development of the ngVLA technology roadmap?
So I'll grab that one maybe. So, you know, one of the goals of ngVLA is to kind of merge the VLA and the VLBA in some conceptual way. But I don't think that that's going to be done to the exclusion of, you know, the really excellent science which has been demonstrated from the merging of the VLBI arrays around the world. And so we certainly expect to continue to, you know, observe in campaign modes in things like the high sensitivity array and maybe dedicated experiments with, you know, EVN and the East Asian VLBI network and so on. So, you know, I think from a scientific viewpoint, I expect that those types of collaborations will continue. The second part of your question there, Paco, about, you know, are other experts from these other facilities participating in the development of the technology roadmap? I think they are to some extent, to the extent that we have review panels and design review panels where we include people from other organizations, and we've included some of our European colleagues on some of these sorts of panels. In terms of an explicit international design process to redesign VLBI technology or something like that, I don't think we're doing that necessarily, but it's an interesting idea. And certainly whatever we develop in terms of connected element interferometry for ngVLA would have to be usable and interfaceable to global VLBI standards. Yeah.
Great.
And it's probably worth adding, so, I mean, some of these folks with the KVN, I mean, they participated in our community study program as well. So they have been engaged.
So the next question at the top. Japan and Canada have long-standing strong involvement in SKA development. Can they realistically join also join ngVLA in a significant way?
Well, I can't possibly speak to the realistic actions of countries. I mean, certainly Japan and Canada have been involved in SKA. The US was also involved in SKA for many years as well. So it's a good question, Eric. I guess we'll have to see as we move forward here. Once ngVLA has got to the point where really there's a need for the international partners to step forward in a major way, that will be the moment where we will see where people's interest lies and where they're going to vote. I will say that we've been discussing with international partners the membership for a couple of years now, and we had set at the very start of the project this 25% foreign partnership goal. Well, I will say that informally we're already kind of at that goal in terms of the informal commitments that we've received from some of the international partners we're already working with. So, that's informal, and there's a big difference between that and writing a whole lot of checks. I get that. But at the moment, the international partnership dimension here is not one that I necessarily worry too much about. I think that there are also things that are changing inside this country to potentially identify new partners and other agencies in the US, engineering and science environment that might want to partner on ngVLA. So it's a good question. I can't speak for Japan and Canada. It was a very positive response from the Canadian Decadal Survey, and we hope to build on that.
Thank you, Tony. So the next question is probably for you. How would operations be funded? Where does the money come from, given that NSF separates construction and operation historically? And I think you already answered.
So the construction money comes from the MREFC account, Major Research Equipment and Facilities Construction account, which is this currently $200 million a year, needs to be $600 million a year diagram that I showed you earlier. The operations for facilities comes out of essentially the home account of whatever directorate or division brought forward the facility. And so if astronomy builds a thing, then the astronomy budget gets to pick up the operations of that thing. So there's, as it has turned out over the course of the last decade or two, that approach was a good approach in the 90s, I think, where the kind of typical increases that are required to operate facilities were within sort of the bounds of the normal growth of these divisions and directorates. But as frankly, as we built ALMA and brought larger facilities online, the type of money that's required and must suddenly be taken from the home accounts of these divisions was much more than could be actually seen in the normal growth of these divisions. And so as we move forward here, that's a big part of this idea that the NSF budget has to double, that really there just has to be more money in here to operate these facilities. And this concept of trying to fix the ratio of operations to construction is an important part of that. There are also discussions underway with the NSF and with some people on the Hill, just talking about the fact that old model doesn't work anymore. And maybe NSF is going to have to think about an operations account where they actually explicitly pay for the operations of large facilities. And NSF itself is having those discussions and has done a pilot program on that type of approach. So it's one of these things that needs to change in the system here for any of these major projects this decade to be successful, and those discussions are underway.
How much does success of ngVLA require more efficient technologies? That is, less stress on the environment, such as energy consumption and dangerous materials.
Okay, so I would say, we consider like sustainability a mandate as we're going forward. But in terms of more efficient technologies, I mean, we're very comfortable where we are right now. And I think any additional improvements or efficiencies gained is really icing on the cake. And, you know, through our design development activity, we're looking for these efficiencies, but as of right now, they aren't required for us to really go forward. I don't know if Rob wants to add to that.
Yeah, just to maybe provide a little detail too. When Eric talks about where we are today, our current projection is that an individual ngVLA antenna will be about 3 times more energy efficient than a VLA antenna. So we've already done a lot to improve that efficiency. And and the final point is that as part of that mandate to consider sustainability, we look at what we consider whole life cost. So we look at the cost of decommissioning and recycling the instrument at the end of the day as well. So that is part of considered the total cost and impact. The environmental impact is included in that.
Thank you, Rob. Next one. Can you say a little more about ngVLA's planned connection with Arecibo/Puerto Rico, especially given the recent events there?
Sure. So I can probably comment on that. I mean, as we have been showing on diagrams for two or more years now, it is our hope to put an ngVLA long baseline array site with 3 antennas at the Arecibo Observatory. And, as I mentioned, that antenna would be roughly 3 times more sensitive than an existing VLBA antenna 100 kilometers away at St. Croix or something like that. So we have very specific calibration reasons and scientific imaging reasons why we wanted to do that. And those have not changed. And so, after the events of a few weeks ago, we have already reached out to our colleagues at the University of Central Florida and had some discussion with them about the fact that, we took to the decadal survey a plan to put a long baseline site at your observatory, and we still want to do that. That's still our intention. And so I think as we move forward here, obviously there's going to be a lot of discussion in the community about, what the future of Arecibo Observatory is. We very much hope that the ngVLA site there will be part of that discussion, and we still plan to do that for sure.
Thank you, Tony. I think next I'm going to combine a couple of questions here, and Rob will probably be the better person to answer them. So will atmospheric seeing affect the ngVLA images? And could you briefly explain the benefits of water vapor radiometry for calibration as opposed to other methods, for example, GPS-RI water vapor measurements? Or perhaps there is a reference to a design study.
Yeah, so we absolutely do have to consider the atmosphere and calibrate out its effects. Ionosphere dominates at low frequencies. Tropospheric effects are the most significant at ngVLA operating frequencies, especially above about 10 gigahertz. And so we compensate for atmospheric seeing through calibration. And as Bob's question hinted at, WVR is our preferred approach, but we have considered a number of other methods. We looked at how feasible self-calibration is most of the time, paired array calibration, especially for the core, WVR, and the trusted backup of fast switching. And the array actually accommodates a number of these. So WVR is enabled, fast switching is enabled on sort of 30-second cycle times, and paired element calibration is possible for a good portion of the array as well. The main benefit to WVR in our mind is twofold. One is the cycle time, which we would like to be correcting errors on to support dynamic range requirements, is a bit fast for fast switching. And so that pushes us towards WVR for more rapid corrections. And the second part has to do with observational efficiency. The longer we can be looking at our science target, the more clock time is actually spent on source, the more efficient the array is. And we're using our observation hours as effectively as possible. So this is all work in progress, and as far as why GPS drive measurements aren't adequate, we did study that, and it looks like the error compensation would be off by about a factor of 10 from what we would need. So it's not quite accurate enough given the spatial distribution of the satellites.
Great, thank you, Rob. Next, does the ngVLA design allow adding remote antennas simply in an organic way? What drives the cost of adding sensitivity by adding more antennas?
Yeah, I'll take that one as well. So the array is highly scalable. So we can absolutely add more antennas and appropriate processing capability. And it's almost a linear relationship. So add dollars, add antennas. There is a bit of a limitation we reach, and that is in the post-processing system, where the number of baselines increases exponentially with the number of antennas. And we would move out of a regime where storing the visibilities and post-processing the data becomes feasible. But that's still quite a bit outside the current 263 antenna envelope. If we doubled the size of the array, this would definitely be a problem. But in the sort of add 10, 20% to the array, we probably wouldn't end up with an architectural change.
Can you please comment a bit more on the timeline for projected receiver development?
Yeah, so this has been something we front-loaded. And so today we've got conceptual designs for all the feeds. And when I say that, there's actually been a pretty extensive parametric study of that parameter space. I think we've done parametrically over 20,000 feed designs, for example, as part of optimization of the optics. So we think we have antenna optics and feeds that are PDR ready effectively at this point. The design of the RF chains, the LNA, down select, and all of that, that'll all take place over the next 4 to 5 years, including prototyping.
Can an ngVLA be copied for the Southern Hemisphere?
There are going to be 2 fantastic telescopes, or 3 fantastic telescopes, depending on how you define it, in the Southern Hemisphere, looking at those guys. There are still opportunities in the Southern Hemisphere, I think. One of the collaborations, one of the discussions we've had is with some of our colleagues is about increasing the VLBI footprint in the Southern Hemisphere to work on problems like celestial and terrestrial frame tie and so on. So there are parts of kind of the routine work that we do in the Northern Hemisphere that are more difficult in the Southern Hemisphere. There's more water. And so there are opportunities for, we're not going to copy certainly the core site would seem like an extraordinary thing. But the idea of having some ngVLA antennas in the Southern Hemisphere to tie the hemispheres together for certain types of observations, that is being actively discussed. And so, maybe there's an opportunity there. But for a lot of the science goals, I agree with Tyler's answer that there are perhaps other ways to have a go at that.
Are there plans to phase up the ngVLA?
Yeah, sure, I can take that. And the answer is yes. Yeah, the design supports phasing up the array, and there's a requirement to be able to work both in a phased array and interferometric mode at the same time. So the answer is yes.
Will there be any consideration for a low frequency extension of the ngVLA, for example, 15 megahertz to 1.5 gigahertz?
So while not part of our reference design, from when we started to work with the community to put the science case and the technical definition together, folks did come up asking for low frequency capabilities. So while not formally being cost as part of the design, there are opportunities to maybe do a bolt-on primary low frequency receiver. You can find actually, I think either an ngVLA memo on this, so it's called ngLobo. So leveraging the work that's already been done with the VLA for P-band work on the primary focus.
Let me add something to that. I mean, I think this is a possibility, and we could add a low frequency receiver, and that ended up being a very successful thing to do on the VLA antennas. The discussion about ngVLA is very much part of what we're doing here, is providing infrastructure that in fact other experiments can be built on. So, we're running fibers to a lot of places around the desert Southwest. So some of these concepts like ngLobo and so on might appear very differently in some ways. I mean, we could have an ngVLA site where adjacent to it, there's a site much like the long wavelength array. So this has been part of the discussion with our colleagues at UNM and at NRL and so on, that there are opportunities like this where in some sense people could build telescopes, instruments which are quite different in terms of their physical receiving characteristics, but would piggyback on the backbone and be able to take advantage of the investment that's made. So this question of putting low frequency receivers on the ngVLA, I don't know that that's the best idea here, but possibly, taking long wavelength array sites with us around the desert Southwest to enable all that science, that would be a fantastic idea. I think the other part of this question I would say is too that when we did think about ngVLA, and I mentioned earlier this idea of finding life between SKA and ALMA, I don't know that there's a lot to be gained by having a lot of duplicated infrastructure. I think as a field we're much stronger if people have great areas of focus and they produce the best instrument they can, and the sum of all those instruments is provides you the broad coverage you need. and we're all operating under sort of similar open skies type environments. So yeah, I would say if someone came forward now and said they really wanted ngVLA to go to 800 megahertz or something like that, I'd probably say you should talk to the SKA people. And yeah, that would be the way I'd approach it. Yeah.
Thank you. So the next one is probably for Andrea. So which pulsating giants will be resolvable by the ngVLA?
Right, I can try to answer the question and provide some number related to the video that Eric showed. So the video that was this simulation of the ngVLA was made assuming a star like Betelgeuse in terms of stellar radius at a distance of about 200 parsec. And the angular resolution in that video is about 1.5 milliarc second, which corresponds to roughly 2% of the stellar radius. So at 200 parsec, you can resolve about 2% of the stellar radius, something like Betelgeuse, which give you an idea of what kind of AGB star you can observe. If you go to 2 kiloparsec, then you are resolving down to a level of 20% of the stellar radius, which is probably still good enough to do some of the science, but you will not get a very sharp image. So, out to 1 or 2 kiloparsec, that's probably the volume that you can reach and resolve the photosphere of these stars.
Can the mysterious dust formation processes in stellar atmospheres be studied? So I can try to answer that. First, I don't think we have a science case in our science book about this particular topic of dust formation in AGB stars. It would be interesting to have one. So, William, if you are interested in this and find out that it's actually doable, writing a science case would be incredibly useful. My personal impression is, without being an expert on the field, is that probably the better way to do this would be to actually look at the molecular precursors of dust in these atmospheres. And I don't know, I haven't looked to see which ones have lines in the band for the ngVLA, but you would try to do something with titanium oxide or something like that if it happens to have a line in the passband. So that would be my quick answer to this particular topic. Is ngVLA planning to participate in defense initiatives? How would that affect observation time available?
I don't know if I should answer an anonymous question about defense initiatives on the internet, but anyway. The radio astronomy facilities, we already have participate in different types of initiatives. We do surveillance and we think about problems that are, sometimes outside the astronomy world. And as we move forward into ngVLA, our capabilities in those additional areas are also improved alongside the astronomy capabilities. So, I think there is, the hope that there will be some engagement and interest with some of these other communities. One obvious one I think that's coming forward is radar, with the change of what's happened with Arecibo, some of the work that's been going on in Green Bank and we've been thinking about for NRAO in terms of radar work. That's the type of sort of adjacent application that we will think more about in the future. So how will that affect observing time? I think that primarily we're building ngVLA to do some amazing science, but there's, a time at the level of sort of 20% plus or minus, I would anticipate available to do some of these sorts of activities. So I don't think it's going to have a strong impact on the science performance of the array. And I do think it opens us up to new communities and new resources for development that will benefit astronomy and these other sort of adjacent activities.
Thank you. And actually, there is a new question that show up in the Q&A, which is related to the point that you were just making, Tony. Can you say a bit more about possibly expanding the community significantly? The radio community has grown in recent years, but there are still many opportunities for expansion in number and diversity, for instance, through community colleges, four-year colleges, etc. Is this part of the plan?
Yeah, I don't know if is Anya online? I don't think so. So I'll have a go at it and then maybe Eric will clean it up. So, certainly the mission of NRAO is to promote broader participation and to improve diversity and those sorts of concerns as part of our routine operations. So one thing that's become quite apparent already, I would say, from things like the Sky Survey, and will certainly be true for ngVLA, is that we are going to need support from the community in terms of, computing cycles and people, proposing science experiments and all of that. So we do imagine reaching out to new communities. Right now, we have a great example where we're trying to create essentially radio astronomy centers of interest in the HBCU communities, HBCU organizations around the US. So I think there are just amazing opportunities in terms of engaging with, other sort of non-traditional partners in radio astronomy, getting people involved in, what we're doing and what we're thinking about for the future. And so the answer to this question is absolutely yes. Currently we have the Radial project at NREO where we're doing this. We have our NAC9 programs where we're trying to produce a pipeline of new, minority serving programs. We are doing this now. We want to do more of this in the future. And if people have ideas, please reach out to me or Eric or Anya Fury is our Director of Broader Impacts at NREO. And we'd love to hear your ideas about this. I don't know if you've got a...
I mean, the only thing I would add, I mean, yeah, clearly we're looking to take advantage of all these great initiatives that exist, but we are, taking the time to look for specific opportunities that the ngVLA will enable through this development of a strategic communications plan by Anya. So.
Great, thank you.